Hello everyone, I'm Paul and today we're solving problem 3342, find minimum time to reach last room 2. This is the second part of a problem we solved recently and the video is in my channel. So I recommend you to go and watch that video first if you haven't. And now let's start with this one. We're given a grid which represents rooms in a dungeon, and each value in the grid represents the minimum time in seconds where we can start moving to that room. And the key difference between this problem and the first one is that moving between adjacent rooms takes 1 second for one move, 2 seconds for the next, then 1, then 2, then 1, then 2, and so on. So if we start here, this will take 1 second to move to an adjacent room, and from here we will take 2 seconds to move to an adjacent room, and from here we are also taking 2 seconds to move to an adjacent room. So that's literally the only difference between this and the previous problem. The first observation we can make is that this first value is useless because we are already in this first room. So this could be any value. This could be a 5, a 10, 100, or whatever. So the minimum distance to reach to this room is 0. Now the minimum distance to reach to this room is the maximum between 0 and 4, which is 4, plus the steps. So the minimum distance to reach here is 5. The minimum distance to reach to this room is also a 5. And similarly, we can reach this last room from here by taking the maximum between the current time and the time of the last room and adding the current seconds required to move to an adjacent room. So in this case, the result is 7. So we return 7. Now for this problem we are also using Dijkstra. So now we will go with another example and how to solve this. Now let's say these are the rooms in our dungeon and we start here at the source and we start with a time of 0, and initially we will set every other time to infinity. And each time we are trying to move to adjacent rooms. For example, if we are trying to move here, we will take the maximum between the current time and the required time for the next room, in this case 6, and we are adding here 1 second. So here we are using 1 second to move to adjacent rooms. Here we will use 2, here we will use 2, here we will use 1, and so on. So in this case the maximum between 0 and 6 is 6, and 6 plus 1 is 7. And if 7 is smaller than the current distance for the room that we are trying to go to, so if this is smaller than infinity, we can update this and replace infinity by the current value, which is 7. And we will apply the same logic here. The maximum between 0 and 79 is 79, and 79 plus 1 is 80. And 80 is smaller than infinity, so this is now 80. Now we have two rooms that we can work with, this one and this one. And the question is, which one should we go first? The answer is the one with the lowest distance, in this case this one. That's why we are using a priority queue, and that's a key part of Dijkstra's algorithm. So in this case we are working with this room and we want to move to this adjacent room, so the maximum between this and this is 32, and 32 plus 2 is 34. So 34 is smaller than infinity, so this is now 34. Now from here we could also try to move here, but let's see what happens. The maximum between 7 and 94 is 94. 94 plus 2 is 96. 96 is bigger than 0. So in this case we want to keep the 0. Now let's continue. We can work with this room or with this one, but we are taking this one because it has the lowest distance, which is 34. So the maximum between this and this is 34, and 34 plus 1 is 35, and 35 is smaller than infinity, so this is now 35. Now the minimum between this and this is 35, so we are working with this room. And the maximum between 35 and 62 is 62. 62 plus 2 is 64, which is smaller than infinity, so this is now 64. And now this one has the smallest distance, so the maximum between 35 and 82 is 82. 82 plus 2 is 84, so this is now 84. And now we are here. The maximum between this and this is 64. 64 plus 1 is 65, which is smaller than infinity. And now we are here, and the maximum between 65 and 69 is 69, plus 2 is 71. Now we are here, and the maximum between 71 and 42 is 71, and 71 plus 1 is 72. And similarly, if we go here, the maximum between 71 and 84 is 84, and 84 plus 1 is 85. And now we are here, and the maximum between 72 and 30 is 72, and 72 plus 2 is 74, and that's smaller than infinity, so this is now 74. So now we know the minimum time to go from the source to the last room is 74, so we return 74. Finally, time complexity for this algorithm will be big O of nm log nm, and space complexity will be big O of nm. And now let's go with the code, and hopefully you will get the idea. First we'll say n equals length of move time, and m equals length of move time at 0. And now we want to create our priority queue. And here, basically we have two ways to know how many seconds do we need to use to move to an adjacent room. In this case, we are just storing the amount of seconds with the current room in the priority queue. So this will have the form of W or wait, or the minimum time required to reach the room, I pointer, J pointer, and seconds. We are adding this. And for example, for the first room, this will start with 0, 0, 0, and 1. And next, we will create our distances array. So dist equals an array, and this will have another array with an infinity, and this is times m for every value in range n. Okay, this is how we create the nested array. And the distance for the source 0, 0 is 0. And now, while we have something in the priority queue, we want to pop the first value, so we can use this. And this will give us a few values: wait, I pointer, J pointer, and seconds. And now we want to iterate every adjacent room, so we can do that like this: for direction I, direction J, in every direction. The new I will be direction I plus I, and the new J will be dj plus j. And now if we are out of bounds, so if new I is smaller than 0, or and j is smaller than 0, or and I is greater or equal to n, or and j is greater or equal to m, In this case we are out of bounds, so we want to continue. And next we want to take the maximum between the current weight or the current minimum distance to the current room and the value in the grid move time at new I and new j, and we want to add seconds. Okay, so we are adding these seconds, which are initially 1. So this will be our current value, and now if this value is smaller than distances at the new I, new j, we need to update distances at new I, new j with the current value. And now we'll say next underscore seconds equals 2 if seconds are currently 1, else 1. Okay, so at first our seconds are 1, so we are updating that to 2, and if our seconds are 2, we are updating this to 1. And now we want to add this room to our priority queue, so heap priority queue dot heap push in our queue a room which will contain the current value, new I, new j, next seconds. And finally, with this information we can return distances at n-1 and -1. So this is the entire code, and now we'll submit this and see if it works. Here I'm missing an n, so I'll fix this and try again. This should be if, not in. So now I think it's right. Let's try again. And now this works. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.